Okay, so here's a more detailed explanation of this section. I'm calling it the lesson. This is typically what we would have done during class. So this is all about the unit circle. So here's a quick snapshot of what it is we are looking at. This is going to mean so much more to you by the end of the lesson, and it's going to be so useful. You're just going to love it. So as we talked about before, um, with the notes, I'm just going to review here, is we are working with the three basic shapes of right triangles. The 30, 60, 90 triangle, the 45, 45 triangle, and the 60, 30 triangle. Now these two are just opposites of each other, but we will work with 30 degrees and 60 degrees also. So that's why they're both here. So when we look at these, we want to know what the distances are. And we've put the hypotenuses is all 1, and you'll see why when we build the unit circle. So that means when the hypotenuse is 1, the short side is half of that in a 30, 60, 90 triangle. And the long side is the square root of 3 times the short side, which is 1/2. So it ends up being the square root of 3 over 2. And so then these are the opposite. This would be 1/2, and this would be the square root of 3 over 2. And in a 45, 45 triangle, the leg is the hypotenuse divided by the square root of 2, which if you rationalize the denominator, you end up with a square root of 2 over 2, and both of the legs are the same distance there. So then we could look at some values that will help us. So the sine of 30, if you look back at the triangle, so I'm going to jump back and forth a little bit here. So the sine of 30 would be 1/2 divided by 1, which is just 1/2. So we are going to be doing some on the assignment that has to do with finding the exact values. And this is how we're going to do it, is we're going to use those triangles to help us. So if we were looking for the sine of 45, I'm going to think of the 45, 45 triangle, that the sine is the opposite side over the hypotenuse. The opposite side is square root of 2 over 2. The hypotenuse would be over 1, so it would just be square root of 2 over 2. The sine of 60 would be the opposite side, square root of 3 over 2 over 1, so just the square root of 3 over, or square root of 3 over 2 divided by 1, so it's just square root of 3 divided by 2. Cosine is the adjacent side, so it would be the adjacent side over 1, so just square root of 3 over 2. Cosine, and you kind of get the idea there. So that's how we're going to use those triangles to help us find the exact values. On the assignment, you will also be asked to find the cosecant and the secant and the cotangent and the tangent of those. So that unit circle is going to be very helpful for you then too, because then you could just look on here and use those triangles, knowing that the sine is the same thing as the y value and the cosine is the same thing as the x value. So that's going to be super helpful there. So what would, just as a quick review of that, so I went over that really fast, what would the x and the y coordinates be? So this is hopefully a review, because hopefully you've looked at the notes already on this, but the point A here would be the distance across the x-axis. So that would be the square root of 3 over 2. That would be the x value of the point. And then the height would be the y value. And we would do that for all of the points. So for A, square root of 3 over 2 and 1/2. For B, let me slide that over here. For B, that point right there would be the square root of 2 over 2, because that was the coordinates on the 45, 45, and square root of 2 over 2, because the legs were the same length. And I'm going to scoot this down here. So this one, it would be the opposite of A, which is 1/2, and then the square root of 3 over 2. That's what all those 3 points right there would be. So, let me move this over. So, as you fill that in, we would have square root of 3 over 2. And then hopefully, along with downloading the notes, you also downloaded that blank unit circle. And your job is to complete that. And here's how you would do the first quadrant, completing that unit circle. Because then the next part would be to look at the points at 0 and at 90 degrees. Because at the point 0, that's just going to be 1, 0. And at 90 degrees, it's going to be 0, 1. Then you could fill in the table with all of those points. And as you do that, you should also then notice that if you took the sine of 30 degrees, you end up with 1/2. And if you took the cosine of 30 degrees, you end up with the square root of 3 over 2. If you put that in a calculator, you get a decimal answer. But if you think about the triangles when you're doing it, then you end up with the fractions as answers. So what is the correlation between the sine and the cosine and the x and the y? And you should notice that the sine is the same thing as the y value, and the cosine is the same thing as the x value. So that's kind of easy to remember because cosine comes before sine alphabetically. So the cosine is the same as the x and the sine is the same as the y. So then you could say, well then, let me fix that. Square root of 2 over 2 and square root of 2 over 2. And then the 60-degree angle would be 1/2 and square root of 3 over 2. So then the sine is square root of 3 over 2, and the cosine is 1/2. There's all the answers. Okay, tangent, you just kind of have to think a little bit differently. The tangent of 60 degrees, tangent is opposite over adjacent. So the tangent of 60 degrees would then be, so if we did the tangent of 60, or this is the 60-degree triangle, then we think of the lengths. This was 1/2, and this was square root of 3 over 2. So if you take the square root of 3, so opposite would be square root of 3 over 2, and then you divide that by 1/2. Dividing by 1/2 is the same thing as multiplying by 2 over 1. And you could think of, oh, the 2's just cancel out, so the answer is just square root of 3. So that's how we find the tangent, is we take the opposite over the adjacent. Okay, and I think we went over this already. Coordinates of D would then be 0, 1. What is the sine of 90? So the sine of 90 would be 1. Let's extend this out a little here. Sine of 90 would be 1, and the cosine of 90 would be 0. So in your notes, you should have downloaded this blank unit circle. Make a copy of it and put it in your notes, and let's fill it in. So first thing we'd look at is, let's start right here at 1, 0. Since this is called a unit circle, that means the radius all has units of 1. So this first one would be 1, 0. Now the next one, I'm just going to quickly draw this. Picture this triangle in here that's the 30-degree angle, only now the hypotenuse is 1. So if the hypotenuse is 1, then this is the short side. That's going to be the 1/2. And then the long side is going to be the square root of 3 over 2. So the x distance was the square root of 3 over 2. And the height, or the y value, is 1/2. I'm going to jump to this one and look at this with this triangle here. And so if we move that triangle in, then you see how that works. Okay. Then we also have this triangle, and I'm going to look at it in the next quadrant over, because this works for this angle, and the corresponding ones in the negative part of the unit circle. So 45, 45, so this coordinate would be the square root of 2 over 2, but we're going in the negative direction, so it's negative. We're still going up, so it is the square root of 2 over 2. And then looking at, find the other triangle, the 60 triangle, if we place it, oops, sorry, need to flip it around. Oh, no, we're going to come down here. With the way that that's oriented, it's going to fit right there, pretty close. So if you remember the 60, 30 triangle, this is the short side, so it is 1/2, and this is the long side, so it's square root of 3 over 2. So in the x direction, we're going negative 1/2, so this value right here would be negative 1/2, and then we're going down square roots of 3 over 2. So you can see by just using those 3 triangles, and then looking at the points, like this one would be 0, negative 1. Then we can then complete. And completing that, that would be negative square roots of 3 over 2. We could also look at this point down here, 0, negative 1. Okay, so now what I'd like you to do is to go ahead and take that blank unit circle and that's in your notes and complete all of the points on the circle. So pause the video and go ahead and do that. Also, as a quick review, looking at cosine, sine, and tangent, how those are related to the unit circle, we would then say the sine of theta, we could look at the sine is going to be the y values. And the cosine is going to be the x value. Now, the tangent, that's kind of an interesting one, because if you think about the triangle, let's just look at like the 60 one. So the tangent is going to be the opposite side. So that's the y over the adjacent side. So that's the x. So that's a really easy shortcut to remember, that the tangent is just the y divided by the x. So here's a quick